So when they're giving off burning gases, sometimes it's putting off a flame, but most of the time it's not. But it's always giving off heat.
No, but in that particular photograph, if you look to the right of it, just to the left of the more vertical moon, the thing that actually occurred, that is
It's nothing to do with the rigs. The argument has nothing to do with the rigs. Get over it, lads.
It does. I'm sorry, it does.
Well, no, it does because it's red herring. Red herring fallacy, that's all you do.
Yeah, it doesn't have to do with the rigs. Those are just marking how the distance. But if you look at the bottom of the rigs where the oil rigs are, those legs will be bent to hell and back. They're not because the most refracted area is on the surface of the rig.
Herring fallacy. Let's talk about the oil rigs. Let's not talk about the actual argument.
Yeah, I think we ought to get back to the geometric horizon being about 2 miles, and we're seeing 10 miles in that argument.
Exactly. That's it. That's the argument. It's nothing to do with the fucking refraction. It's just, yeah, look, you guys said looking at the oil rigs.
Yeah.
Nothing to do with the
oil rigs. If you want to dispute the observer height not being a foot, then we can argue about that. But you can't argue that you're seeing too far.
Blue, exactly. Do you have that image? Do you have the screenshot of the different day where you wrote your modus tollens on?
Yeah, I do. I could find it for you.
Yeah, I think we need to discuss that one.
Let me take a minute.
Oh, well, we need to discuss the fact that you guys can't even understand a simple argument.
No, we need to discuss less anomalous data and compare.
And we need to also discuss that Blue Marble's gas pressure vat container inside a container.
What height would the person need to be?
What's that got to do with this?
If you're actually seeing the horizon.
It just goes to show you guys get asked the question, you don't fucking understand the question, you answer the wrong shit. It's hilarious. I'm sure one day you guys will actually get what we mean by gas pressure vat container, and also why the refraction of the oil rigs is absolutely irrelevant to the fact that you've seen 10 mile horizon. That's what we want the actual question answered.
I mean,
give me teach me that. Teach me.
In your mind, are you not the least clueless person here?
Kosho, what would
you're the most smartest person I've ever met, Kosho. Honestly, I wish I could be as intelligent as you are.
Kosho, what would the height on a globe? What would your height have to be to actually see the horizon?
Blue Marble Science was robbed of a response.
Okay, so go ahead. I just logged in. I didn't hear that. Go ahead.
I don't even know what I was responding to now. I think my question is, what the hell does gas pressure without a container have to do with this?
So just want to try to play
gotcha with me.
Oh, sorry, sorry to attack you.
Is that what you like?
It's to do with the fact that you're asking the question, right, and then you don't really understand the question. Then you blame flat earthers for being stupid when, we asked for a demonstration for a gas pressure without a container. Well, there you go. Well, who's the one who's trying to show gas pressure?
You're the guy. Hey, listen, hold on a second. You want to go there? We'll go there right now. You're the ones that defined what a container was, and it had to have a top on it.
All right.
It had to be a sealed container. You only changed that. You decided to move the goalpost and change the rules after I proved you were wrong.
So you used the container, right?
No, I used an open pipe. By your definition, that is not a container.
Is a bucket container? Hold on. Let's see how smart you are. Is a bucket considered a container?
What?
Is a bucket considered a container?
Is a
bucket. In a bucket. If I get a bucket of water, right?
Depends on what you're talking about. Yeah, it's perfectly fine.
I'm talking about a bucket. Yeah, so it's a container.
You can even pour assholes in one of them, but it's no good for gas, buddy.
All right, so
not a container for gas.
So you're intelligent. You're very educated and very, you're obviously not that stupid, but you are a bit dumb if you don't realize that having a lid or something doesn't change the fact that it's a container, does it?
Yeah. Listen, aren't you guys always saying that unless there's a dome up there, unless there's containment on the atmosphere, our atmosphere would fuck off into space? Isn't that your exact words?
Nice red herring fallacy, mate. But the point I'm trying to say to
you it's not a red herring.
It's not a red herring. It's not red herring. It's on the same topic.
A bucket is still a container. Yeah?
Not for gas, it is. I'll tell you what, do this.
It's a container, mate. A bucket
take a bucket down to the local center that fills up propane gas cylinders for you. Take a bucket down there and ask them to fill it full of propane and see what they do.
So what about that thick gas?
Doesn't change the fact that hold on, percentage. Hold on, percentage, please. Let me deal with this. Let me deal with this, jabroni. Let me deal with this, jabroni. Listen, the bucket itself does not change. By definition, it's still a container. Don't care if it's not able to contain certain gases. That's not the question. The actual bucket itself is still a container. So having a lid of something doesn't change the fact that it can contain things, and it's still by definition a container.
No, it's not. It is not being contained.
Okay, all right, son. All right, mate. You're so intelligent. You're so dumb. You're so smart when you need to be, and you're so dumb when you need to be.
I mean, we get it. You want to see gas pressure next to a vacuum without a container, okay? So you're right. What you're saying is correct, man. So is it cool if, in showing this to you, can I do this in a vacuum chamber? Because to have a vacuum, I got to be in a vacuum chamber. Is that cool?
And the vacuum chamber is a container. I know where you're going.
Yeah, so stop being a jackass, dude.
The way to get around that.
To do this in a vacuum, you're going to need a vacuum chamber.
The way to get around it. So you still don't understand? Okay, talk over me, because you don't like my response. You never won the argument. Yes, I know where you're going with the fucking fact that you need a vacuum to make a container.
Like my fucking god.
Oh, here we go. More goons getting involved. You guys are so dumb. It's ridiculous. You are actually stupid. I'm just going to say that. That's the end of my conversation.
You don't even know what refraction is, and you're debating it from me.
Yeah. I don't know what it is, man.
You said you didn't.
Yeah, so I don't know what it is, man. You tell me. It makes things look flat, apparently. It makes balls look flat.
So, do y'all say, are y'all saying this image is due to refraction, or do you think that he's lying about his altitude, being that you can see 10 miles further than you should? So which is it?
It's refraction, man.
So he's telling the truth. It's actually...
If you use any curve calculator, any calculator that tells you where the horizon is supposed to be or how far you're supposed to see, it'll say, as a disclaimer, at least in the ones I've seen, as a disclaimer, this does not work near water or near the surface, near water. It'll say this on the curve calculators, because there's refraction that exists there that are going to do things that are not going to be predictable. So in the case of this picture, you're getting that exact example. Something that's happening that you may not have been able to predict. It's not a big deal. It's just the real problem here is that someone's done this observation in these conditions. Do an observation like do any other observation. Do the long distance observation, the longest shot ever taken at whatever fucking mountain that is. Okay, and calculate for how far you're meant to be able to see, and add standard refraction. And guess what? You're right within the bounds of what you're supposed to be able to see. Okay, so use conditions where this isn't a problem.
That part with the camera is because it's a flat plane, dude. Not refracting.
What are you talking about? There's not refracting. Refraction is present in everyday life. Every day. How can you say that anything taken on Earth doesn't contain refraction of any level? How can you utter those words and believe them?
I'm a bit wrong. Okay.
But come in here, okay, Professor. All that yes man stuff that you deal with over in 24/7 is going to be scrutinized. All your claims and everything you say over there in safety, it's a different story over here.
Yeah, there's a point I was just substantiated right there. You take Lake Conague, or I'm sorry, not Lake Conague, is it? Whatever mountain that is, Mount Conague, whatever it's called. You take that observation and you look at the height of the observer, peaks that you're seeing. You take standard refraction alone, nothing extreme, and guess what? You find that you see exactly within 5 miles of the distance that you're meant to be seeing.
Yeah, it's mad, isn't it? It looks flat. Looks flat because of refraction. Refraction makes things
doesn't look flat because of refraction. If it looked flat because of refraction, you'd be able to see Mount Everest as well.
Yeah. I'm sure. If we did see it, you'd have a reason for it. I'm sure. Yeah. Because
So
The,
if
re-
you're
the,
saying,
the, the
oh,
refractive
hold on.
index or the reflection alpha?
If you're saying it looks flat, therefore it is, are you saying that the bar crane in the Black Swan picture is actually bent all up like that? Because it
No,
looks
I'm saying that you're saying the Earth's curved, and you have to prove it. But I don't see any curve, and I'm yet to believe it because you're telling me. Hold on, they're trying to say that the Earth's curved. They're going to prove that it's curved. That's it. And when they come up with like, oh, the reason it looks flat is because it's bending like, then I'm like, okay, well that's not really proof, but it's a good suggestion.
So you're
Learn about
saying
refraction, Brummy.
So you're saying the burner
So
arm is actually all bent up like that?
I think you should.
It looks flat. We all need to agree it looks flat. That's it.
Why does this look like it's not flat?
Cool
It look-
Brummy
that's
leave.
Because
That looks like graphics.
the video is sped up. That's why. That's why it
Okay.
doesn't look flat and wavy and shit like that. Because it's
Kosho, you got Jem's show to go on now, yeah? Make sure you don't
It's
forget
not
to go
on
Jem's
yet.
show.
It's like
Talk about
half an hour away.
Let me ask you guys,
I've done flat earthers though.
why is it that everything everything that we have needs to be discarded completely, like the pictures of Earth from space, or the fact that refraction's a real thing? These ideas have to be discarded and thrown out in order for your world to exist.
Exactly.
No, they don't.
One picture from space and it's all over. That's why, Coach.
Yeah, from actual space.
from actual
Like the
space,
satellite
dude.
photo here.
You think
If
that photo's real? Let me hold on.
It is absolutely real. Do you want me to send you the original?
I just
Really?
say we're not discarding them all. Generally, people try to bring up stuff about like, hey, look at this little orbit. And we're like, oh, we're not discarding that. We can verify that shit. You know what I'm saying?
Yeah. Well, that image I just posted is 4K. So, yeah, it's a little bit
That looks
more
like
than.
computer. It looks like computer.
I think we
graphics.
should shine a
Sorry.
light up at it. Next time we should get the laser pointer right on that bitch, and then we could verify it.
This is
Like we blinded out
geostationary.
Himawari. Like let's do mission blind Himawari.
That's been done too.
This is GoAS 16, Brummy.
Yeah.
I believe Moyak for some reason.
No, they did a laser pointer when I saw that.
Moyak's not somebody to fuck with either, dude. He used to bring his gun to school as a kid.
Fucking A, man.
We're safe outside of America right now. It's okay.
I'm surprised I didn't get you pussy later on, man.
No, because I kept on shooting it.
Moyak's not somebody to fuck with. If he says the Earth's round, I would trust him, man. Or at least I would pretend to trust him.
Wait, you trust someone with a freaking gun to, yeah, I would.
You better trust me, motherfucker.
If someone that had a gun, I was with them or, knew them, and they were like, the Earth is round. Like, you better believe I would be like, yeah, the Earth is round, because I would be afraid I might get freaking shot, dude.
You're right,
Like,
you're right,
really?
Earl.
There you go.
No, Earl's right. Earl's right. But at the end of the day, that's why I always say in here, that's why you don't need to do that. You don't have to,
That
threaten
just
somebody
means
to
you're a
tell
freaking
the truth.
scaredy cat.
Yeah,
Nah,
exactly.
the Earth is round
just makes
whether I
smart.
shoot you
It
or
makes
not.
smart. If you're gonna deny something or prove something because somebody's got a gun in your face, then that's different, of course. So
That just means you're a
but
coward. Stick to your conviction.
Reason why I believe the major reason why I believe the Earth is flat, because I have never, ever seen, like, the Earth, the horizon line go down because the Earth was curved. And the Earth isn't curved, it's flat because the horizon always rises with you.
How sure are you about
No,
that?
it doesn't.
The last thing you said.
Well, sadly, it doesn't. If you go up in an airplane, it's 3 degrees down. If you go up on a balloon, the high altitude balloon, it's 7 degrees down.
Climb a mountain, you'll see.
Really, 7 degrees?
I wouldn't mind having a chat with Phil KO. If you want to do a 1v1, I'm happy to go to a different room and have a chat with you if you want that. I'm not really fussed. I can easily just explain to you why you guys just need to just, open your mind to the fact that you could be lied to.
Bill, make sure he's wearing pants when you do that.
At about 60,000
just
feet,
wake up, man.
it's probably like almost 6 degrees down.
These
Might be
pictures
some
of
degrees down, but you're seeing a lot more of the plane because you're going up.
Yeah, no, but that's not what's in question. Take any frame, your frame of vision. What Moyak is saying, and I hope what you're also denying, is that your frame of vision, the line that is the horizon, is not going to be halfway in that frame. It's going to be lower and lower and lower as you're rising up and looking perpendicular to the ground. That's important
Horizon
too.
never rises to eye level is a better
what does
statement.
perpendicular mean? What's perpendicular mean?
90 degrees.
Yeah, the horizon
That's
never
what I like
rises to eye level is the proper answer.
And for all the bullshit that's been said, I like you, brother. Because of questions like that.
You like me? Because I actually really stupid.
No, it's honest because you have honest questions though sometimes, man. You have honest questions.
Well, you didn't really jump to answer that quickly. So it makes me believe that you don't really know what you mean when you say perpendicular yourself.
Fair enough.
Well, Brummy, you presented the black swan. What about if I present this to you now? What are you going to do about it?
I might talk about something. I might talk about
what are you
what
ready?
you did and talk something.
What are you going to do?
I want to talk about do what you did.
What are you
give
going
me an argument?
What are you going to do with the white swans? All right. What are you going to do?
Well, if you look at the you see that little pixel at the bottom left corner. All right, if we look at that little pixel.
Yeah.
Right, let's look at that pixel. That pixel, and you see the pixel. That means therefore we can't trust anything on this image because of that pixel there. And that pixel at the bottom left. Right, you can see that pixel at the bottom left. Like that's what you're doing. You're not talking about the swans.
No, but you see, can you not see what I'm showing you here? These swans were taken in the dark, and look, that water's reflecting the swan. See?
Yeah.
What are you gonna do then now?
The swan, man.
What are you gonna do now? The water.
Let's talk about the darkness. Let's talk about the darkness. Look at the darkness, man. Look at where the darkness is refracted. That's what you're doing. You're not talking about the actual argument.
Oh, the water's reflective. Game, set,
talking
match.
about the darkness, man. Sad, I think, really.
You want to see more reflective? Look at this beautiful sun. No, this is New Zealand. You should really visit.
Oh, I thought the picture. I thought that was the picture you just posted, the one from the Birds movie.
Well, look how flat that looks. But the reason it looks flat is because the water's curving.
No, it's not.
It's not flat.
Up. Yes, it is flat.
No, it's not.
Yeah, it looks flat
There's a
because
curve in there,
the water's
buddy.
reflecting.
No,
it's reflecting over it.
Wait a minute.
It's looming.
If it were curving, it would be curving down.
Just appreciate how beautiful New Zealand is, all right? Just.
I know New Zealand's beautiful.
Yeah, we got oceans too, man.
What kind of women do you have in New Zealand other than Lucy Lawless?
Oh my God. Don't answer that stupid ass question.
This is a stupid ass question?
Yes, it is a stupid ass question.
I agree, it's an ass question. Yeah, ass question. And the ass
so it looks flat because the light's bending over the curve, right?
What about do you wipe your own ass? Is that a stupid ass question?
It looks flat because it's bending.
My sister was just like,
it's not bending.
Well,
yeah, Professor Earl, how do you tell if something's bending?
If you can see it, you can see if something's bending up or down.
But what is it that you see that indicates to you that it's bending?
I'm not saying it's bending.
Hold on. When something is bending, how do you perceive that?
You perceive it by by the view that it's bending.
But what about it tells your eye, tells your mind that it's bending?
Because you can see the bend in the object that you're looking at.
How do you see bend is my question. What is it about it that allows you to see bend?
Just tell him what you mean, because he's not getting it.
Well, what the frick do you mean?
Okay, here I'll ask you a question. You ever draw?
Yes.
You ever try to draw a sphere? What do you do to make that thing look spherical? Because all you get is 2 dimensions, right? You draw it on a flat piece of paper. What do you do to make that thing look
You make
spherical?
a circle. You make it circle.
Then it just looks like a circle. What do you have to do to make it look like a sphere?
You shade it.
There you go.
Shade it
You shade it, right? And that's how we see spheres, right? That's how we see things curving, by slight differences in perception of either color or shade, right?
Not always. Sorry.
What other case is there where you can see? Well, how else can you see a curve without a difference in color or shade?
The difference in shape if it's curving.
Difference in shape, dude.
But what indicates the difference in shape if it's not color and shade?
Sometimes it's not color or shade.
Yeah.
Sometimes it's the object that we see. We have binaural vision, dude.
Okay, what does that do for you?
That allows you to have depth perception.
How does depth perception indicate curvature?
Because it lets you look at it from another angle.
Right.
You guys really have no clue of how vision works, do you?
No, you're.
You don't. You're making it more complex than what fucking needs to be.
No, I'm making it exactly as complex as it needs to be in order to understand it.
Well, that
without shading.
Yes. Try to draw a picture. Draw a picture and make something look spherical or curved without shading. Give it a shot. See if you can.
That's not like in regular everyday life. That
is
really,
exactly.
No.
You may not recognize it, but you look at anything and you can tell. The only way you can tell anything is curved is by changes in shading or color.
No.
No, that is.
No.
Try it. Look around your house.
It's all three.
Look at a doorknob, for example. I'm looking at a doorknob right now. That's a sphere. How do I know it's a what in my eye tells me it's a sphere other than
because
it's got a white center in it from a.
Hold on. You see the light the refraction of you see the light, the shininess in it has an image that has it and it's distorted. So you see the distortion, on the door handle that's round.
You're telling me I'm looking at this door handle right now. I see distortion? I don't see any distortion. It's very clear to me.
Well, if it's around, you see it's a bit distorted with what shining, with the light shining. It's a reflective surface, right?
This one is, yeah, but it doesn't have to be, right? I'm looking also at what am I looking at? It's round around me right now. I'm looking at a clock frame. I'm looking at from the side, and I can see it's round because the shading changes. I see a white line practically in it, right, where it's.
That's because of the light. It's not all the way around it.
No, that's exactly my point. It is because of the light, but what about the light tells your brain that it's curved? It's the difference in shading and color. That's it. There's no more. Right?
But you're making it more complex than what it needs to be.
No, to say it's difference in shading and color is about as simple as it could possibly be, right? You're the one who tried to add on some curviness that you just somehow detect magically.
No. There's no magic involved here. Sorry.
So what is it?
It's reality, dude.
Huge red herring. What's
Yeah,
this even?
we
It's a
agree.
red herring fallacy.
we agree that all your eyes see is photons hitting your optic nerves, right, and give an indication of color and intensity. Do we not?
Because of the cones in your eyes that gives you the freaking color.
But that's literally all you perceive, right? Is differences in color and intensity, is it not?
Yes.
Okay. So, from differences in color and intensity, our brains determine that something is curved, right?
Because of our binaural vision.
Because of differences of color and intensity, is it not?
And angles.
And angles.
Wait, well, hold on. How do we determine angles? How does our brain determine that something's at an angle? Because of differences in color and intensity.
I have a question for you.
No.
So let's say we all see an object, right? We know how an object looks. We know what curvature.
Well, I don't want to move on thing until we agree on this thing. Then we'll
the
just
same
keep
thing. This is
disagreeing
the
about
same
everything.
thing. This is the same
Okay.
thing. So we know how an object looks. We know that it's not curved, right? And someone comes and does.
How do no, not right? No, I can't. How do we know it's not curved?
Just from personal experience.
No, but how do you know? No, you're still avoiding the
right?
question. How, from your personal experience, do you know it's not curved?
Yeah, I agree with you, man. With shading and with our binaural vision, we know from from living our lives that this object, this hypothetical object, is not curved, right?
Yes.
But
Okay.
then you can falsely shade it, right? And you can make it so it seems like it is curved.
Absolutely.
Right?
Yep.
Okay. So it doesn't. So you can still trick this thing. You can have illusions.
Absolutely.
As far as what you're talking about.
Like this floor that Mr. Reality just posted.
I'm gaming, so.
Yeah, well, he just posted this floor that looks like it's all wavy and everything because of the tile.
That's because it's an optical illusion.
Well, we know that. But how do we distinguish between illusions and non-illusions then?
Personal experience.
Yep, exactly. Personal experience.
That doesn't answer the question. Because because you still have to determine which one is an illusion, which one is not an illusion, and just saying personal experience doesn't answer the question of how you determine.
You go down to the floor and check it out, and, you know, or step on it and see if it's wavy or not.
I agree. That's how you and I would both do it, right? And we agree to that. We agree that would be a reasonable thing to do, right?
Exactly.
So we're in agreement there, right? We agree on that. How would we tell if the Earth is curved?
We would go up to a higher vantage point to, see,
Well, but you said it looks flat. You said this water you're looking at, it's flat. How would you tell if it wasn't?
But if it's curved, if you keep on going up, you should be able to see the shape.
Yeah.
No, hold on. We don't have that ability right now. We're looking at a single picture. I'm looking, who just posted one of the ocean. Rocky had just posted one of his many things that he posts.
If it were curved, and you're looking out over the ocean, right? So you're looking at the ocean.
Yep.
So you're looking out, you should see at both ends with your eyes, you should see a dipping of the horizon.
Okay.
But you do not see a dipping of the horizon.
What about the picture would I be able to see to indicate dipping? What would I see change to indicate dipping?
Going off at the end in the far distance of your
Wait, what was that again? I'm sorry. What would be in the far distance?
You would see a dipping in the far distance.
You just repeated that. I need to know what I would see visually to indicate.
Visually, you would see it curving down near the
do you not see you're just repeating the same thing over and over? What indicates dipping or what indicates curving? You can't say dipping and curving indicate dipping and curving. What should I see that I could tell that I can say
you
to me is optical?
you're looking out, right?
Yes.
So you look out on either side, right?
On either
From your
side, right and
left to
left.
right, right and left,
Uh-huh.
you should see a curving going down as you're looking out.
Oh, so I should see a rise in the middle of my vision, of my field
No,
of
you
view,
should
and
see it going down.
well, going down would have to indicate that's going up somewhere else, right? Otherwise, I have no
No,
reference
if
for
it's
down.
if you're talking about a globe, right? A globe Earth,
Sure.
right? So if the only way you would think that would be going up is if the Earth, if it was a concave Earth, which you were inside the Earth. If you were on the outside of the Earth, you would see it curving down.
Okay, I should, maybe I'll phrase this question differently. Let's say I'm drawing a picture, right? And I want to draw what I'm talking about here. And so I want to draw an ocean, not take a picture. I want to draw the ocean, and I want to, in my drawing, indicate to the viewer, to anybody looking at my picture, that this line or that this plane or whatever is dropping off. What would I do to indicate that on my picture? How would I draw that?
It would draw the horizon. It would make a horizon line that would show the top, a departure from the top and the bottom. So you got your horizon line.
Yeah. And so if I would just, so are you saying I would have to draw side to side curvature or just depth curvature?
It would be side to side. And
like this.
So you're saying the fact that I don't see side to side curvature is the reason I can't say that it's curving at all.
exactly. Because you're looking out, right? So you got the depth.
Yeah.
So you're seeing out. Well, you should see the curvature on each side, or slight curvature.
Why?
Because you're not high enough up to see the full curvature.
Yeah,
If the Earth was round.
It sounds to me like you keep switching back and forth between the two different curvatures. There's a curvature going away from you, right? Is that true?
Right, it would be going away from, but you would.
There's a curvature going side to side, right?
Right. So it's curving away from you and side to side of you. That's what that's what it would do on a flat Earth. I mean,
Like
on
this?
the globe Earth. You know what I mean.
So like this picture?
Which picture?
The basketball one.
Exactly. But because you're so
It just sounds to me like you're saying because the Earth is so big and our eyes, our humanness can't see that level of curvature, then you got to assume it doesn't exist. Is someone saying something I don't hear?
No.
Okay.
that's because they have it way so freaking close that looks flat.
Yes.
Because here's the thing, Professor. I was just down in Monterey the other day, standing on a cliff and looking out at the ocean, and the ocean kind of, if you have a 180-degree view of the ocean, I mean, you're right on the ocean and you're pretty high, and you can look to your left and you look to your right, and the land is tall. That ocean seems like it's wrapping around you, right? If you took a picture of that, that thing would definitely be curved. There's no question about it. It would show up on you.
That would be
if you took a picture, those pixels that create that horizon would not be a one line, right? They would definitely be a curve. But that, I'm not saying that proves the Earth is round, because if it were like a big ass pizza, you would get the exact same phenomenon, right?
Scott, I think you did miss something. He did have like a little moment there where he said that the basketball looks flat because it's so close. Exactly. That's the problem. We're seeing the world from very close.
The picture Scott's painting is that you're either having some weird limitation to vision to where it looks like you have 3 miles in every direction, I think, or you have a drop off at everywhere around you.
Yeah.
Attention,
Yeah,
moderate.
but you don't have
We
a
have
drop
an
off.
eater on microphone. Mods, we have an eater on microphone.
I swear I'm not eating. I swear, Curb. I
Stop
swear to you.
eating the microphone. It's not helping for you.
Get him, Earl. Get him.
Licking your dildo while you're talking, okay?
Okay. Because every time I hear this conversation, I think it's kind of odd, because I swear I see the Earth curving. People tell me I can't.
I don't see it curving, dude.
I think I do. I swear, and maybe it's just an illusion. Maybe it's just me I swear I see the water getting darker towards the edge. I swear I see that
because it's
curve.
further away from you, so it looks darker. You said about shading, right?
Yes.
So it's gotta be different from out of your visual range.
Yeah,
That there would be a color disparity from what's closer to you than what's away from you. So
Who says the water isn't darker? It could be.
It could be, but that to me looks curved. And I'm wondering how you guys don't see that as curved.
It's probably just an illusion like the floor.
It could be, but how do you know it's not? Or how do you know it is? And how do you determine which is an illusion, which is real? That's exactly my question before.
You measure drop from horizontal over 1 mile.
How do you know which is an illusion and which is real? That's my only question.
Here's the thing. So, if it were round, you would not be able to, because the ship goes over the curve, as you say, right? So the
I
ship
watched
goes
that
over.
several times, yes.
Okay, ship goes over a curve.
Yep.
So it's over the curve. You cannot see it, but you take your binoculars.
No, that's just not true.
That is true.
Well,
you bring it back into image because
no,
it's
you
further
can't.
out.
No,
yes,
no,
yes,
you can't.
yes.
Okay,
yes.
I'm going to ask you a direct question, Professor Earl. Have you ever done that yourself, or are you just going off the video someone showed you? Yeah, okay, I got to call bullshit on this.
Here's a picture for you.
No, you're lying.
I'm not lying.
You are. I've done this many times. I sat on the Golden Gate Bridge watching these tankers come in and out, and I watched them go over the horizon. I sit there for hours as they go away and come in.
Well, you must really block off traffic.
No, there's walking areas in the Golden Gate Bridge. You ever been there? It's beautiful. When it's not foggy, you can see for a very long ways.
You ever think about jumping?
No, but let's get back to the point. So I've personally watched these boats come in. And
Did you have binoculars?
And I watched them down in LA County too, around
Did you have
San Pedro
binoculars with you?
Yes, I did. And yes, it does exactly like this picture this other person just posted, again, that they've posted 1,000 times that Flash Burn just does. Those ships disappear from the bottom up every time.
That is not that is an optical illusion.
Wait,
because
hold on,
of how your eyes work.
Hold on. Did you just said I could bring them back with binoculars?
Yes.
And now you're saying the fact they disappear is optical illusion. Which is it? Can I bring them back with binoculars every time?
It's an optical illusion because of how far it's out in the waves.
Hold on. Are you saying I can bring them back with binoculars every time?
That's what I heard.
Binoculars are strong enough?
With binoculars every time. Is that what you're saying to me?
And if it's not opacity in the atmosphere that causes
I'm talking to Professor Earl at this moment. He made a claim. I just want to make sure I understand his claim. We're not talking past each other.
Refraction.
No, that's not my question. You said with binoculars I could bring them back. Are you saying every time?
Not every time because of the distance and the power of your binoculars.
So when these ships disappear and all I could see is the, I don't know, smokestack. I don't know smokestacks anymore, but there's some part of it in these antennas that are on the top right. And when all I can see is that and I can't see the rest of the ship, you're saying there's some power of binocular or some power of something that I could use to see the rest of that ship. Is that what you're saying?
And that fin or whatever, that smokestack on that cruise ship seems to take up like I don't know, 20% of the screen. It's as big as you can get it.
Yep. It simply can't be disappearing from perspective. I mean, it's too damn big.
I can see the pimples on that kid's face from there.
If you can see his pimples, then it's not far enough to be obstructed by
exactly
the curve.
Fine, no, didn't get distracted from the pimples, guys. Come on. Stick to the question. Earl, are you saying I can bring them back every time?
Not every time because of the power of your binoculars.
Okay, so not every time. Now I want to rephrase the question. Anytime. Can I ever bring them back? A ship that size, when it's done that kind of thing, when all I can see is the top antenna part or whatever that thing is on the top of the tankers, sometimes it's just the bridge. When all I can see is the bridge, is there ever a time that I can bring back the rest of the ship?
Part of it.
Part of it.
Sometimes.
Like
is there ever a time I can bring back all of it?
You have like super strong resolution on your camera or on
That's
your
why
lens?
it said to him.
So we should be able to bring it back.
Depends on the atmospheric conditions.
Exactly. It's atmospheric conditions.
My next question. Have any of you actually ever done that?
I haven't. How's that relevant though?
So you guys are saying we can do this thing, and you've never actually done it. You've never seen it done, but you somehow know you can do it.
What are you asking?
Are you denying that, like the conditions for eyesight, the limitations for eyesight?
No, look.
I'm not asking you that question. I want to know if you could ever bring the ship back.
Right, that claim has been
made. Have you ever
made.
seen it happen?
He wants the qualification to the claim.
Yeah,
I've never been able to bring back a cruise ship or a tanker.
Videos like hundreds of times.
No, only for little boats.
Hundreds of times a tanker you've brought back.
I told you part of it. And if it's the entire thing, why are you pigeonholing the?
Well, what part of it have you brought back?
Which part of it did you bring back? Yeah, which part?
You're shifting the goalposts, bro.
No,
which part did you
bring back?
He's setting up the goalpost. I don't think it's fair to say that at this point.
Which part of it did you bring back? Which part did you bring back?
Part of the nearest part to the top.
What? So you're talking little tiny objects you couldn't see on them that you can now see the tiny objects? Or are you talking about the bottom coming back?
No, it disappears bottom up and it reappears top down.
You've brought back extra of the vertical.
Vice versa for things on the ground.
Yeah?
Never seen that.
They say they've never seen it, bro, and I still haven't either. I thought we had this when Flat Earth first started. It was all that trickery stuff, man.
No one has ever
all those
produced
videos
that
with
video.
like Nikon P1000.
Wait. Hold on. I asked if you ever done it. Now you're saying all those videos of blah, blah, blah.
Did I not?
Okay.
Does it matter?
I missed it. Sorry. No, you said it. I believe you, but I missed it. That's my fault. So have you ever thought about going on and trying this for yourself? Just because you're curious? And
I'm nowhere. I'm in the city and I don't have that camera.
No.
So when I'm in.
It seems to be you folks that are so interested in the truth, in the real truth. I mean, some of these things are so easy to do.
But I don't understand the implication. Are you claiming that this doesn't happen? That we can't bring things back?
Yes.
Well, the thing is,
not of the required size to actually bring them back.
Under the goalpost he's setting, under his goalpost.
But yeah, if there's a little tiny ship that you can't see with your eyes, and you get binoculars, yeah, you can see that little tiny ship.
Which it still seems like a fair goalpost.
But the thing is,
but no, you're never going to bring back the bottom of a tanker. Never.
The thing is, we have two mechanisms to explain why that is. One,
no, we don't. We only have one.
The other one is perspective, making the horizon line compress at the eye level of the observer, making back the image. So we need to explore which option is happening. Angular resolution.
Okay. I'll go with you on this one. So you're agreeing that you're never going to bring the bottom back, no matter what you do.
Sometimes you can, but if you go beyond
no, but we just established that it's never happened. No one's ever seen it.
The limitations of sight are the resolution of the lens, the observer height, and the atmospheric.
I get all that. Before we can go into that, we have to agree on simply what has been seen, right?
So if you're saying we have absolute free reign on controlling those, then yes, you could bring it back. Whether it's done or not,
hold on.
No, because we have limitations. That's why they're limitations.
Okay, let's just agree on the facts first. Make sure we're all working from the same facts. We agree that if you're standing on a bridge, Golden Gate Bridge or something, as a tanker goes over the horizon, heading off to China or Mexico, or to, Japan or wherever they're going, most likely China, that once they go so far out there, you cannot ever bring the bottom of that back. Do we agree on that?
Yeah.
Without changing the variables?
I agree with that.
That's what I said, standing on the bridge. We can watch that thing, and I don't care if you get binoculars or a super telescope, you're never going to see the bottom of that.
You've reached your angular resolution. You've reached your...
Yeah, but do we agree? Do we agree to that fact?
Everyone agrees with that.
Okay.
You said you could get binoculars, you could get anything, and you can't bring it back. That's not the
Yes.
case.
No, that is the case.
That's only the case if it disappeared finally due to atmospheric refraction. But if it was disappeared due to observer height or to the lens, then you can bring it back.
What you need is you need to find something that disappears due to angular size before it disappears due to obstruction.
Yeah, but nothing ever does. Yeah, but
fine.
That's why I'm using a tanker or a cruise ship. I don't see many cruise ships actually coming out of San Francisco Bay, but there's all kinds of tankers and cargo ships, and they're huge. And those have never ever come back. Nobody's ever shown one of those coming back, right?
Well, eventually they come back.
Yeah, when they turn around and come back from China, yeah, and on their return trip, sure, they come back.
Well, they bring it back up to a point, but the thing is,
no,
the
they
goal
don't.
is
They just don't.
That point and say you need to move it past the resolution of the optic, where it compresses into the eye line of the observer, and that's the true
blah blah blah. No, they don't.
So basically, you have a bunch of goalpost movers on the globe side that need to submit their globe to analysis and falsification.
No, they don't.
Mountains don't disappear, Lemon, from great distances on a clear day.
How can you what?
How come mountains don't disappear?
Because mountains don't move.
I mean, eventually you're going to get past the resolution of the optic, and it's just going to converge into of the observer.
So have we agreed the boats don't come? The cargo ships and tankers don't come back?
This is the third time that we agreed. Are you going to make a point or not?
I agree. Only
explain it.
Due to atmospheric opacity.
Angular resolution at the eye level of the observer, where the top and bottom half of your vision merge from diffraction in the eye. You can accept it or reject it. If they have an alternative explanation, you can accept it or reject it, like it or lump it.
No, you don't, actually. Show me the math. When you have the math, you can have then you have an alternative explanation. Until that, you just have words.
I agree.
That aren't predictive in anything.
So long as it's disappearing due to the, amassment of atmospheric capacity due to the distance that it's traveled from you.
That just it's never a phenomenon. It never happens. Things don't disappear because of that.
Really?
Yes, really.
So you're saying that because we know that the atmosphere is more more dense towards the surface. Saying that as something goes farther away, it's not going to have more of this density, more of this opacity than if it's closer?
But on a flat Earth,
I'm saying,
actually,
not that you're going to see.
And think about it, on flat Earth, you wouldn't be looking through a change in medium. You'd be looking straight through a uniform medium.
Yeah.
Yeah, but it still scales, bro.
It doesn't. No, it doesn't. You're looking straight.
No, you need to provide the math to say that scales. No, it doesn't.
Over a distance.
No, it doesn't.
I get it. I know you'd have a cone and you have a triangle going on there. I understand, but just think about a general thing. Man, concede if he's got. Don't say we have something we don't have. Okay, that makes at the end. That's where they're going to call us dumb, right? Why would we do that? Why would we be dishonest? They're going to call us dumb and dishonest.
Bro, what are you even talking about? You just said that you don't have more atmosphere over distance. I don't even know what you're talking about.
Man, I'm saying you ain't seen nothing big, right? Disappear due to the angular size down into a pin dot before you've seen it obstructed from the sea level.
That's not what he said. He said there's absolutely no way to bring it back, and I agree with
Which
him.
equivocates to what I'm saying.
Capacity. But you could bring it back if you have like an infinite lens with infinite resolution with your lens.
No, you wouldn't.
If it didn't disappear due to opacity, then yeah, you can. You can make up for.
Here's what you're saying.
It's got nothing to do with opacity because the size of the change doesn't shrink to a dot before, or does it go into fade? It drops from the viewer. Okay, and when you get optics that zoom right out to that point, you can still see where it used to be, but no, it's no longer there. So the optics aren't your problem. The curvature is. And then the other point that was moved away from the horizon dropping, rising to eye level, climb a fucking mountain and tell me that. Because I tell you what, I climbed the tallest mountain in the North Island of New Zealand and I couldn't see the rest of New Zealand. Why not?
Hold up, sheeple. The optics are the problem because the human eye has a minimum resolvable angle of like 0.02 degrees. You have optics that make that like minimum resolvable angle way lower, then you're gonna be able to
right. So you would see something.
The diffraction limit wasn't reached before it moved out of view. Nice try again, but the diffraction limit, a light coming to the eye, was not lower than the observer limit before the thing physically left. So stop trying to fucking wiggle out of reality.
Let me give an example. I don't want to pile on percentage, but let me give an example. You're equivocating to something like, say you're at 10 times zoom, and that thing goes, it looks like it's out to the horizon, it's going, and it gets down to a little pin dot. Then you're saying you could pull out a 20 times zoom, and that pin dot would enlarge back again, right? That's basically what you're saying. Agree or disagree?
Yeah, only the reason you couldn't see it was because it went below the minimal resolvable angle.
So is that an agreement, basically? Or no?
I've been saying that for how long?
Okay, so we're agreeing, right? So, but where is the evidence of this? Is the question.
Then you
There's no. It doesn't matter if you go percentage. It doesn't matter if you go from 10 times to 100 times, from your eyes to 10 times, anywhere in between, man. Like this phenomenon should be evident.
But the thing is, you're not talking about how much of the object is distributed above and below the level of the eyes. That is appears to be what's happening, why things are disappearing behind what we interpret as a horizon, because everything's converging at the eye level of the observer.
I mean, we got stuff that can zoom. We got shit that can zoom, 1,000 miles away, man. Like, what? You seen these? You seen this shit, bro? They zoom like 80,000 times or some shit. It's crazy, bro. Excuse my background noise.
Yeah, this conversion claim doesn't help you when you switch to true optics, ground telescopes and things. It's not going to help you. Because now the limit of the observer is nowhere near the limit of the optics that you're using. Doesn't explain why you can't see the rest of New Zealand from a high vantage point on a flat Earth.
Right. But you're not talking about how much of the object is above or below the level of the eyes based off of where you're looking, the direction that the object is going off into.
Like if
something's going off parallel to a flat plane,
there's no distortion or conversion or none of this bullshit. It's the water level itself that's forever changing.
We're Giscalping, man. Listen. I don't want to, Lemon. Before we go to that variable, we need to make agreements on the previous variable. I mean, seriously, like this really getting messy.
The question, Don, is the philosophy used to interpret the facts. We can't even have facts here because we have different philosophies to interpret the phenomena differently and make it a different sort of fact. So let's look
but listen, but even on the first scenario presented, It seems like we have a it seems like no matter which philosophy you come at it with, people like me or Sheeple or these other people trying to go